Not only does the duplication of individual genes or several genes increase information, but sometimes organisms undergo a wholesale duplication of their entire genome. And sometimes, not only does this not kill them or harm them, but it actually confers evolutionary benefits. Juan Carlos del Pozo and Elena Ramirez Parra write the following in the Journal of Experimental Botany. Quote, "Polyploidy is a common event in plants that involves the acquisition of more than 2 complete sets of chromosomes. In spite of inconveniences derived from chromosomic rearrangement during polyploidization, natural plant polyploid species often exhibit improved growth vigor and adaptation to adverse environments, conferring evolutionary advantages. These advantages have also been incorporated into crop breeding programs. Many tetraploid crops show increased stress tolerance, although the molecular mechanisms underlying these different adaptation abilities are poorly known." End quote. Nicholas Panchi et al. Provides some specific examples. Quote, "Recent whole genome duplications that have occurred in the lineages of several domesticated crop species, including wheat, cotton, and soybean, have contributed to important agronomic traits, such as grain quality, fruit shape, and flowering time." End quote. Although more commonplace in plants, this process is not exclusive to plants. As we read in Molecular Genetics and Genomics, quote, "Whole genome duplication events have shaped the history of many evolutionary lineages. One such duplication has been implicated in the evolution of teleost fishes, by far the most species-rich vertebrate clade. After initial controversy, there is now solid evidence that such an event took place in the common ancestor of all extant teleosts. Recent studies let us conclude that teleos-specific whole genome duplication has been important in generating teleos complexity, but that more recent ecological adaptations only marginally related to TSWGD might have even contributed more to diversification. It is likely, however, that TSWGD provided teleosts with diversification potential that can become effective much later, such as during phases of environmental change." End quote. To reiterate, this is only a smattering of the countless examples where these processes have taken place. Strangely enough, creationists apparently reject the idea that this disproves their argument. As Alcorn and Darnall put it, quote, "Mutations are thought to drive evolution, but they cannot increase information. Mutations can only change DNA by deleting, damaging, duplicating, or substituting already existing information." End quote. I'm sorry, but if a gene or the entire genome gets duplicated, and if these duplicates diverge from the original genes and take on new functions, which give the organism a survivalistic and reproductive advantage, this is a clear example of mutation increasing genetic information in a manner that benefits the organism. Can you show me an example of mutation increasing information? Yeah, here's an example of a general process by which this happens across the entire biological world. Those examples don't count. This is textbook special pleading right here. Yes, actually those examples do count, because they demonstrate precisely what you're asking us to demonstrate. These examples also plainly refute the claim made on creation.com that, quote, "selection involves getting rid of information," end quote, because as we've seen, selection can also involve duplicating and modifying, and thus increasing information. I'm on Patreon. There's a link in the description if you'd like to support my content. I would really appreciate it. There's also social media links in there if you want to follow me there. I'm trying to build up some of those followings. I would really appreciate it. Make sure to subscribe for more videos if you haven't already. Hit the bell, hit the like button, post a fucking comments. All that fun stuff that's standard on YouTube. You know the fucking drill. Thanks for watching. Hope you enjoyed this.